Ocean technology is what happens under the water, on the water, and above the water.
Really, if you boil it down, it's a combination of different disciplines coming together to develop products and innovate.
It's just anything where you're collecting data or you're using technology just in and around an ocean environment.
One of the reasons that Canada is so unique is that we have the longest coastlines in the world. It's the way that we obtain our food, way that we transport goods.
Ocean technology is important because we need to develop innovative ways to care for the ocean, monitor the ocean. The ocean is a vital part of our survival as humans.
COVE is a global innovation hub. We started a lot of research several years ago around what's the talent needs in this sector. It's getting students market ready, getting them trained so that when they go in a business, they're just ready to work and contribute as much as they can.
We really wanted Smart Ice to come on board with us. We knew that they needed business people, marketing people, as well as engineers and people with data and computer science backgrounds.
There was a lot of hazards that were coming with ice thawing and refreezing, and it was dangerous for transportation on the ice. And so we helped the communities by discovering how thick the ice is or how thin the ice is.
Taking our technology called the Smart Buoy, which is a big 8-foot tall buoy that can measure sea ice thickness based on the temperature and conductivity of the water around it.
We're trying to preserve the knowledge that the Indigenous communities already possess, specifically regarding the routes of travel for hunting and fishing. And our priority is involving Indigenous youth, as that next generation are going to be vital to preserving that knowledge.
On the Selamaris, there's actually 17 different instruments. It is a location for companies to be able to conduct product development, verification, and commercialization, all in the marine environment. Usually that needs to be done through a chartered vessel, and vessels are really expensive. We have 2 underwater cameras. We're able to live stream the platform as it sits on the ocean floor. 2 instruments called CTDs, so those are conductivity, temperature, depth sensors. The conductivity is what's correlated to salinity, so how salty the water is. Hydrophones, we have 6 hydrophones, and they collect acoustic data.
Hydrophones are very practical. They're used to monitor marine activity underwater, bathymetry, underwater measurements of the ocean floor, or sea floor mapping. So we make piezoelectric ceramics, which sense vibration underwater and convert that vibration into electricity.
As a firmware developer, my job is actually communicating with whatever data it sends in. They come in as a stream of bytes. You have to break those bytes up to translate these bytes and make it into something that does make sense.
Zeos Technologies produce sensors and systems for remote monitoring anything valuable that you put in the oceans. One of our most popular products is an Iridium and GPS beacon. The rover goes on the liquid robotics wave glider, which is used by navies and universities to do months-long surveys in the ocean. It gets GPS fixes from satellites, and then it communicates that back through the Iridium satellite network. It all starts with engineering, but we also need marketing people, we need salespeople.
You don't need to have a background in ocean.
There are multiple paths and multiple roads into ocean tech.
I would say just go for it.
Go for it.
Go for it. You never really know what you love until you try it.
It's definitely kind of reignited my fire in engineering.
Without young people bringing in new ideas, new talent, creativity, we are not going to be able to transform the way that we're doing things. Consider playing a role, whatever that may look like, because we need young, smart people leading us in a different direction. And it's not just boats on the water. It's under the water, on the water, above the water.